Hello guys and welcome back to one more LeetCode problem. We'll try to solve LeetCode problem 707, which is about designing a linked list. This is a quite simple problem, but this is a bit tricky, and this sets the stage for any other linked list problems on LeetCode. So this is one of the basic problems where you will have to understand how do we actually design it, what and all methods we can use to either get the values from the linked list, or insert into it or delete into it. So if we look at the problem, it says that a node is a singly linked list which has two attributes, val and next.val. Next is a pointer reference to the next node. If you want to use doubly linked list, you will need one more attribute, previous, to indicate the previous node in the linked list. Assume all nodes in the linked list are zero index. This is a good info, where we have to treat zero based indexing. So we need to implement my linked list, where we need to initialize any my linked list object and get index, that would get a value from any index. If it's not present, then we need to return -1. All right, I'll not go through all these. Let's try to actually code and see how far we can go with 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 this problem. So before I do anything, let's try to code this part of the problem, where we need to, whenever we create a node, it needs to have two attributes, right? So let's do private class node, and this will have two properties, right? One would be an val subtype integer, and next is a reference which actually points to the node. So we'll say node next, right? Then let's create a constructor here which is simple node into value, and then what it does, it sets the value as val, and it also sets next to null to make it easier. This line of code is redundant, but it's good to have it there. So yeah, then what else do we need to do here? So this part is done. So where we have created in private class for node, let's move on. Now we need two two more we need two more nodes actually, which will hold the references for head and tail. So let's create those. Private node, let's say head, and private node tail. Also, we need to keep a track of the length or the size, let's say size, of our linked list, right? So this is the constructor here, public my linked list. So whenever you instantiate a object, so what should it do? It should set head to null. It should set head to null and tail to null as well, and then size should be 0. All right, so now we have to implement this method where we have to get the value of the indexed node in the linked list. So let's first try to see let's first try to mention that, hey, if index is less than 0, or if index is greater or equal to size, right, size of the linked list, we simply return -1. Okay, now we need to figure out a way where we can reach to the index, so in order to do that, let's create a temporary node. The reason we are creating a temporary node and pointing it to head, because we do not want our head to change. So let's loop through and see how can we reach to our current index. So I'll say I is less than index, because we are starting from 0, I plus plus, and then I can say temp equals temp dot next, right? So once I am done, once I get the temp node, once it reaches there, all I need to do is return the temp dot val. Cool. So then the next one, add at head, adds a node val before the first element of the linked list. So after the insertion, the new node will be the first node of the linked list. Okay, so in order to do this, we have to actually change our head, also add one and a node to the our existing linked list. So what we can do here is, whenever you have an add method, you can simply go ahead and create a new node. Let's say new node equals new node with val, right? Then let's say the current linked list was empty and there were no other nodes. What it means is the size was 0, right? What should we do in this case? We'll simply say, hey, head will start pointing to new node, and tail will also start pointing to new node. Or what we can do is, we can say, hey, my new node dot next, right? New node dot next points to the previous head, right? And then head will be updated with new node. Simple. And then we need to increment our size, right? Similarly, add at tail should be easy. So what we need to do is, we can say if size equals 0, if my head becomes new node and tail becomes new node, right? Of course, we need to first create this new node, right? Or we can simply do, hey, my current tail should start pointing to new node, right? And tail should also be updated with new node, and of course increment our size as well. So the next one is add at index. So what we will do in this method is we need to first get the previous value, right? Or let's try to break it down into smaller steps. um, what we can do is first, does it say we need to return anything? No, this is a void method, right? Okay, let's first do a check. Let's say if index is less than 0 or index is greater than size, but it can be size, right? That will be the size plus 1. Index will be size plus 1 at that time. If you remember, we did here greater or equal to size because that was get, that would be the last element, size would be the last element there. Here we need to check that if it's greater, that if that index is greater than that size, because we can insert at last, right? So let's say we will simply return, because we don't want to, otherwise it will throw an exception. So let's say that if we have to add at index 0, that essentially means to add at head. And return out of it. And if our similarly, if our index equals size, that means we need to add it at tail. Right? And return out of it. Since this is add, let's go ahead and first reach to an element after which we need to add this method, after which we need to add this new node. So we can leverage the get, but get does not have no return type. Okay, so if you look at this logic here, we did I is less than index, right, to get that element. So previous to that, the previous node will be then index minus 1. So we'll simply do node temp equals head. We'll start from the head and then do for int I equals 0, I is less than index minus 1. So we want to get the previous element because that's the one after which we need to add the new node, right? So once this is done, we can simply do temp equals temp dot next. Once I have this, since this is an addition method, we need to create the new node. We can do new node equals new node with the current value, right? But now we need to first tell our new node, hey, you are pointing to your next node is temp dot next node, right? Index minus 1 next node, which is the index node at index, particular index. So once this is done, we can then do temp dot next, right, equals new node. This becomes the new node. And so this was new temp next, it becomes, let's see, one sec. So if I add 0 1 2 4, let's say I wanted to add here, so I got the 1 dot, the new node will start pointing to 3, and then I'm saying that hey, 1 dot next will be the new node in between here, which will be my new node. Yeah, that's correct. So, and we need to finally will increment it. Cool. Is there a return type? No, it's void. So that's done. We can now look at delete method. So let's do the basic check where index is less than is greater than size, right? Greater than size, but this can be greater or equal to size because we're doing zero base indexing. So let's say that we want to remove our head. What will happen when we need to remove our head? So the new head will be head.next, right? Also, we need to take care of one more factor here, which is what if this was the only element, right? Then this line will already take care of setting head to null in case if it was the only element. Then here we need to update null tail to null, right? Once this is done, right, we can actually decrement here and then return, right? Now similar to how we iterate through the linked list, let's leverage a temp node which starts from the head and goes up to index -1 again, because we need to delete the element right after this index. We need to delete the node at index, so that means we need to first know the previous node, which we will get by index -1, and then I increment it. Yeah, so we can say same logic, temp equals temp.next, right? Now which is the node that I need to delete? That's the node right after the temp node, right? Let's write it in simpler terms. Let's say node to delete, right, is which node? Right, the one that's right after the temp equals temp.next. We can simply say temp.next because we looped here through index -1 up to index -1, so temp is the previous node actually. So that's why we do that. Hey, the next node will be the node to delete, no, temp.next. Also, what we need to say is now my temp.next, which is the node to delete, right, will be node to delete, but the one that where it is pointing to, right? So it will be next. So we need to take care of if it was the tail, we will simply do if index equals equals, right, size -1 if it was the last node. So then we need to say that, hey, my tail is now this temp, and then decrement it. All right, looks good so far. Let's try to run it and see. Okay, node to delete equals temporary temp dot next. Oh, right. Okay, all right, cool. Let's try to submit now. Okay, cool. All right, thanks guys, thanks for watching this video.